Hello, I'm Rob Pisamenti, and today we will be looking at how to find the volume of a solid by rotating a region around a given axis. For this question, we'll be looking at the area bounded by the line 2x and the line x squared, and we'll be rotating it around the x-axis. The first thing I like to start off doing is sketch the graph. So as you can see, the line y equals 2x, a straight line, is the upper bound, while the line x squared is the lower bound, and you can see the area bounded is shaded in blue. I also like to sketch important parts in the graph. As you can see, they intersect at the origin and the position 2, 4. There's two ways to find the volume of a region by rotating around an axis. You can either do volume by shell or volume by the disk method. We're rotating around the x-axis, as you can see, and since things are already given to us in terms of x, I'm going to keep it in that, and we're going to use the disk method. Below is the equation, and its volume equals your bounds, pi times your upper function squared divided by your lower function, the one that's bounding it, squared as well. It's also important to remember that this is in terms of x. We're rotating it using the disk method, so you want to make sure everything's in terms of x. Had it been in y, we were using the shell method, the equation would be different. Now we pretty much have to plug and chug. We see that our upper bounds would be 2, our lower bound being the origin, so it's 0. Remember, this is in terms of x, because our functions are set up in x. And the upper bound being 2x, the lower bound being x squared, we just put those into the designated spots when we've set up our equation. The next step I took was to simplify my integral, just to make taking the integral easier. I moved the pi out of the integral and then just use my parenthesis rule to take the exponent, or the raise 2x to the second power, and also x squared. So in the end I got 4x squared minus x to the fourth. As it turned out, simplifying my integral earlier made it much easier to take this integral. So the pi being multiplied by everything because I moved outside the integral. I just used the rule x to the exponent plus 1 divided by the exponent plus 1. And as you can see, it worked out pretty easily. 4 was then divided by 3 because x is now being raised to 3, and then 1 being divided by 5 because x is now raised to the 5th power. So the next step to find the volume in between our bounds, we just take that integral of the function using x equals 2 minus that same function, however, x being equal to 0. So when simplifying this further using basic math, we get that when x equals 2, the function equals pi times 32 divided by 3 minus 32 divided by 5. Luckily, when x equals 0, the function also equals 0, so that makes it easy for us as well. So now the next step is just to subtract. Finally, we get that our volume equals 64 pi divided by 15, and that's pretty much it. The steps, just remember, it's a lot easier if you write it out or draw it out so you can visualize what you're doing, and make sure you're checking whether you're taking it with respect to y or x. That'll all depend on what method you're using. Now, just to give you a visualization so that we can kind of understand what we're doing instead of just this abstract calc. To the left, you'll see the graph, and we see that area bounded by the two functions that we saw earlier. As we can see, that's like rotated around the x-axis, creating a conical shape. To the bottom, you'll see just that basic cone, which is what the shape is. Now, to the right of that, if we were to cut a cone in half, that's what we would see. And so that's what we're taking the volume of, is that area shaded. Now, I hope that this is able to give you some context so that calc can become more concrete and you can understand it easier and kind of take away from that voodoo of calc.